So number 24 on the second multiple choice worksheet. Implicit differentiation is the fancy word, but the main thing is if you take the derivative of y, dy dx shows up. So minus x times, we can go shorthand and call it y prime if you want to, or we can keep it with dy dx, either way. And then plus the other way around, y times the derivative of x, but the derivative of x is just 1, plus 3y squared dy dx equals, and then here's a favorite mistake. I don't know if one of the answer choices includes this mistake. It should if it doesn't. What's the derivative? When I ask it like this, everyone gets it right. What's the derivative of 1? 0. But sometimes if there's a constant over there, people forget about it or don't take its derivative and just leave the 1. And obviously that's going to mess them up. So a little bit of algebra ahead of us here. 3x squared minus x. I'm going to switch to y prime just because it's easier to write. Let's see. So I'm going to factor out the y prime of the stuff that I can factor it out of and move the other stuff over. So doing a bunch of algebra steps in one there. Factor out the y prime, move the other stuff over, and then start looking at my answer choices. Y minus 3x squared over 3y squared minus x would be C. So that's implicit. 25 is an implicit problem as well. Because what's the derivative of cosine of y going to be?
Not 5.
What's the derivative of cosine?
Negative sine.
Yeah, so negative sine y dy dx. And then you'd have to solve for the dy dx. Let's see, 26, pretty straightforward. 27, product rule, but product rule twice. And then, yeah, because the second derivative, and then plug in 0. All right, but I want to look at 28 and 29. Sorry, which one were you asking about? 24 is C. 28. Okay, so that's a limit problem, but it's not really a limit problem because you're supposed to recognize that that's the definition of a derivative. The definition of a derivative, so I'm looking at 28, is limit as h approaches 0, f of x plus h minus f of x all over h. So we got to try to match up the pieces here. So it looks like f of x is x to the 6th. But we're evaluating it at 1. X equals 1 of x to the 6th. Well, now it's an easy problem because I can do the derivative of x to the 6th. 6x to the 5th at x equals 1 would just be 6. So that one, like the computation is easy, but recognizing what they're wanting you to do is maybe the tricky one. Why don't you try 29? It's a really similar problem. See if you can match up who goes with what.
Oh, oops.
So there's number 30. Make the table and figure it out. 31. The graph of G prime is shown. The graph of G prime is shown, and it's sort of labeled, but we'll make it a little bit bigger there. G prime is what we're looking at. Which of the following statements is true of G at x equals a?
Oh, G. Okay.
Yeah, so, okay. G is continuous.
I'd say so.
Why do you say so? You're right. This is one thing that they love to test.
Oh, I love this.
Because it.
Okay, well, hold on a second. G, this is G prime, so G
But it's
prime
at X of A.
has
Or
a
X-
derivative at A. So that means G has a derivative at A.
Of 0. It's
So it is differentiable at A. And
because we have a point there, yeah.
because there's a point there. Now, the derivative of this graph is not defined. So G double prime doesn't exist. But G prime at A exists. In fact, maybe we should do statement 2 first. G is differentiable. Yes. Because it's whatever value that point is at. So
And
G
is increasing because G prime is positive. Right? That's the.
And if something is differentiable, it could only have been differentiable if it was also continuous. Now, continuous doesn't mean it has a derivative,
Yeah.
but if it has a derivative, it was definitely continuous.
Squares are rectangle, rectangles and squares.
It's squares and rectangles, rectangles and squares. And they can test this in a number of different ways, this fact that differentiability implies continuity. But that's what they're looking for there. The derivative exists, therefore it had to be continuous, because if it wasn't continuous, you couldn't have had a derivative. Now, so I'm definitely good with 1 and 2, which means I would know what the answer is for this one.
Yeah.
G is increasing.
Yeah, because it's positive.
Yeah, because G prime is positive at A. Now, the weird part is, yes, there's a kink there, so G double prime does not exist
Because that's a cusp.
at a cusp, but we didn't have anything about double second derivative or concavity or anything like that. All right, some tables on 33 to 35. Or 31 to 35. One of those numbering got off here somewhere. That means there's two 31s and 32s. Whatever. 32, we kind of did 32 already, but let's do 32. What rule am I going to have to use if B is equal to F times G? How am I going to find the derivative of B?
I don't know. F prime times G prime?
Definitely
no.
not. Not F prime times G prime.
No, it's the
G time.
it's the product
And it's
rule.
the product rule. So F times G prime plus G times F prime. So somehow product rule with equations is easier than product rule with just letters there for some people. But this is a product rule problem. So now we got to look at 2 for all of those things. So F at 2 is 5. G prime at 2 Haven, what's G prime at 2? G prime at 2 is -2. Marissa, how about G of 2? G of 2 is 1. Is that you or Brooke that gets credit for that? Kira gets credit, okay. Logan, how about F prime at 2?
3.
3. And so then we just put all that together. -10 plus 3 is -7. So that one was easy on the computation front, and really no derivatives to take. That was strictly a product rule type problem. 33 is pretty similar, except it's a quotient rule problem. 34, what kind of rule is that?
A yucky one.
Chain rule. So that's our Tootsie Roll Pop rule. Work from the outside in. So that would be F prime of g times g prime. So be careful, don't bite the Tootsie Roll all at once. You need to go one piece at a time and chain it together. And then at 1, this is where things get a little bit weird. It's not f prime at 1, it's f prime at g of 1. So, Peyton, what's g of 1?
3.
G of 1 is 3. Brooke, how about f prime at 3? 4. And Kira, g prime at 1? Negative 3. So 4 times negative 3, negative 12. Uh, 35 is another inverse problem. So we'll skip that one, but that would be set up the table, put in the x's and y's, and again, the grand finale is that it's reciprocals. 37. Function f has the derivative shown. Again, they love doing this where they give you the graph of the derivative and then start asking you questions about f. And this one is especially fun because of how it's worded. Which of the following statements must be false? Must be false. Okay. And I guess before we look, let's think about what's going on here. So there's no derivative at A. I don't know if you'd want to try to draw this or not.
There's a hole of some sort. Like there's some sort of discontinuity there.
Is there a discontinuity there? Maybe, maybe not. Like the slope is a constant up to A, constant 1 or negative 1, or what's a constant something. And then after that, it starts down and goes back up, but it could be connected. Or not. We don't know. It could be connected. It
Could be a cusp.
could be not connected. Like we don't really know. So f is continuous. Maybe. F of A equals 0. Maybe. Because maybe this starts down here and lands at 0, so maybe. F has a vertical asymptote at x equals A. So a vertical asymptote, that would look like that. What would the slope be doing if we had a vertical asymptote? It wouldn't be continuous, but so we've got that. But that alone doesn't mean much. Like the slope of this thing, this is f. The slope's getting bigger and bigger, not staying steady. So I think C is the correct answer because that can't be right. Let's keep going though. F has a jump discontinuity. Well, maybe, maybe not. Who knows? F has a removable discontinuity. Removable just means there's a hole there. So, maybe there's a hole, but maybe there's not a hole. There's definitely not a vertical asymptote because our slope would be getting much steeper if there was a vertical asymptote. So another good, all of these are old AP questions, where that one there was no computation at all. You didn't take a derivative at all. It was all about understanding the concepts. I'll leave the last two for you to do. Let's look at the free response questions. Okay. Couple things to say. I want all free response questions on a separate piece of paper. Okay? I do not want you to try to be a hero and squeeze You know, on the test, this will be like 2 pages worth of stuff, because each little part is usually half a page they give you to write big and to think through and mark out and whatever. It does not look like this on the AP test. Like, they will give you part A and a half a page to do it, and part B and a half a page to do it. They really give you plenty of space.
They want to set us up for success.
Yeah, they're trying to. So on a separate sheet of paper, let's do number 1. All right, the graph of the continuous function g, which is the derivative of function f, is shown. So I'm going to go ahead and label that g is equal to f prime. So they're giving me the graph of f prime and just calling it g to try to mess me up. The function g is piecewise linear, on the places that it looks like it's a line, and then it's a parabola, over there where it looks like a parabola. All right, if f of 1 equals 3, what is the value of f of negative 5? Let's see. So g is equal to f prime. So if I want to know something about f, right, they're asking me f questions, but they've given me f prime. How do I get from f prime back to f? The antiderivative. So I need to antiderivative f prime, or g. So I want the antiderivative of f prime. What limits should I use? From what to what?
Negative 5 to 6.
I think I want to use this point, so I'm going to go negative 5 to 1. So this would be f of 1 minus f of negative 5. All right, I've got f of 1. I'm looking for f of negative 5. Hopefully I can find the antiderivative, negative 5 to 1, of g of x. F prime and g are the same thing. So what does the antiderivative, what else does that mean, especially if I've got a graph to look at?
Area under the curve.
Area under the curve. So area from negative 5 to 1. Okay, so let's come look at our picture over here and maybe draw in some areas. 1, 2, 3, 1, 2, 3. So that 3 by 3 is a 9 block, but I don't think I'm going to label it as 9. I'm going to label it as something other than 9. Negative 9, because it's below. So that's negative 9. Then from negative 2 to 1, that's a triangle, 1/2 base times height. It would be negative 1.5. And then from 0 to 1, and that's where I can stop, another triangle of 1.
Bless you.
So my integral from negative 5 to 1, the area under the curve from negative 5 to 1, is negative 9 minus 1.5 plus 1. And that equals 3 minus f of negative 5. Somewhere in here you got to decide how much of this do you want to safe stop versus actually do the math. I'll kind of leave that up to you. If you really want to be careful, I'm going to move f of negative 5 to this side. And then move all the other pieces to the other side. So plus 9, plus 1.5, minus 1. I'm done. That's a safe stop. Right? You don't want to lose that point by adding those wrong or subtracting wrong. So I would safe stop that. Part B. Evaluate the integral from 1 to 6 of g of x dx. Integral from 1 to 6 g of x dx. Well, that's still, my brain's still thinking area under the curve, because that's what we just did. But what's the problem with thinking about area under the curve? From 1 to 6, especially. What's that, Nick? As a parabola, I don't know what the area under a parabola is. So how else can I handle this integral? What else does it mean? It means area under the curve, but it also means
f of 6 minus f of 1.
Antiderivative. So this is a weird one. So I'm going to do area under the curve from 1 to 3, because I can do that. And then I'll do the antiderivative from 3 to 6. So from 1 to, not 1 to 6, 1 to 3, that's just area under the curve. So that would be 4. So that's the easy part. From 3 to 6, well, I have an equation for g of x. 2 times x minus 4 squared dx. So this is what AP likes to do, right? They've combined two things in one problem. You have to know, we talked about this before, you have to know that that symbol means antiderivative, but also area. I don't know that we've done a problem where you had to use both of them in one problem. But we got the area part, now we need the antiderivative part. I don't think I want to antiderivative that. I think I'd rather antiderivative that. I think that's going to be easier. Algebra first. So let's see, x cubed over 3 minus 4x squared plus 16x from 3 to 6. Giant safe stop coming, right? Like I'm not doing 6 cubed or 6 squared or even 16 times 6.
No.
I'm going to do 6 cubed over 3 minus 4 times 6 squared plus 16 times 6. And be careful, all of that minus, then plug in 3. 3 would be easier to work with, but I'm not messing with that either. But there's my answer. Like I'm not doing anything more than that. So again, with the free response, use the safe stop thing. Okay with that? Part C. And remember, these are hard questions, but you get 15 minutes for each one. And you get lots of partial credit, so you keep going. Even if you don't figure out part A or B, you keep trying. Part C. On what open intervals, so parentheses, not brackets, is the graph of f both increasing and concave up? Give a reason for your answer. Okay. So what does it mean if f is increasing? Let's figure out what that means.
G is positive.
That means
G is positive.
Or F prime is
positive.
f prime is positive, but we know that's the same thing as g, so g is positive. So let's write down where g is positive. That would be from 0 to 4. And it was nice that it said open interval, so I'm not worried about brackets or parentheses. Like I know it's parentheses. Okay, concave up. That would mean
If G prime is positive.
I'm going to back up one more. You're right. I'm thinking that means f double prime is positive,
Which is the same as G prime.
which is the same thing as g prime. And so I have a graph of g. So what am I looking for g prime to be positive? Like what am I actually looking at on the graph of g?
Slope of it.
Good. So slope of g is positive. Okay, so the slope is positive from -2 to -1, from 0 to 1, and from 4 to 6. Okay, but that wasn't exactly the question. Is it both increasing and concave up? So I need the overlap of those things.
Is 0 to 1.
So yeah, just 0 to 1. Again, really not supposed to box your answer because all of that reasoning is part of your answer. In my favorite Facebook group, one of the chief. By the way, don't forget to watch the review video.
Oh yeah.
One of the guys that's on the video, Mark, it's Mark and Verge. Mark is like the main administrator of the Facebook group. Somebody asked about how do you tell your students how much to write on a free response question, especially when it says give a reason for your answer.
Be brief, be specific.
Because sometimes students are like, oh, let me give you a reason and write a paragraph. Like, no, I don't want a paragraph. I just want the calculus reason. And it might be very brief. So his response is, be brief. Oh, I think I'm getting this right. Be brilliant and be gone. Don't linger. Right? It's like, get your answer down concisely, be accurate, and then move on. Like, you don't have to spend time explaining to me, that f prime is positive and go. I don't need all that. Like, tell me what the question asks and move on. I don't want a paragraph. They don't want a paragraph. They want a good, concise calculus answer. Part D. Find the x-coordinate of each point of inflection. Give a reason for your answer. And as always, if you give a reason for your answer first, that usually tells you what to look for. So a POI of f they got track meet and soccer game. Good luck to all 4 or 5 of you.
1, 2, 3. Yeah.
All right, so a point of inflection, how do I know where that happens? Or what would I be looking for? What? Don't say it.
What changes?
The slope
Changes sign.
of G prime
Of
changes
G.
sign. F double prime changes.
Let's start with just the basics. F double prime changes signs.
Yeah.
Because if you start saying the slope of G, I don't know. That might not even be right. Let's just start with what we know.
The slope of G is F double prime.
Okay.
My brain just
let's see, f double prime is the same thing as g prime, right? Because g was equal to f prime, so g prime is equal to f double prime. So where g prime changes signs, and that would mean the slope of g changes signs. And so some of you jumped all the way there to begin with. My brain couldn't make that leap. I wanted to start with f has a point of inflection where f double prime changes signs. Then we'll start tying it to this particular problem. Now we're at a point where we can look at the graph of g and see that its slope changes. Careful, there's places where it levels out but doesn't change signs. Oh, I don't like this. 1 and 3. It's like it doesn't change signs at 1 though. It goes from positive to 0.
Yeah.
That's not a change of signs.
0 to negative.
0 to negative, that didn't really count.
Oh.
But -4.
Yeah. Wait, at -4. That's
I'm sorry, that'd be +4.
wrong side of the graph, Mr. Wolf.
Yes. If I had done that, like part D is probably worth 2 points. Probably 1 for the reason and 1 for the... So if I had made that mistake that I almost did, just not paying attention and wrote -4, I would probably still get 1 of the 2 points. So give your reasons, show your work, and get all the points you can. All right, I want you to try, timing-wise here, try number 2. So you try number 2. I'll press pause, and then we'll go over it a little bit. It's very similar. So you try number 2. So for number 2, it tells us that f of -2 is 7. And even before they give me anything on this problem, I'm pretty sure I'm going to be doing area under the curve, especially when the areas are triangles and circles. So I'm pretty sure I know where we're headed with this. Part A, find f of -6. By the way, those are my guesses for point values on this problem, so I don't really know, but it's almost certainly 2, 2, 2, and 3 somewhere. So to get f of -6, I need to integrate f prime to get to f. They told me what f of -2 is. So if I go from -6 to -2, I'm looking for -6. They told me f of -2. And so this is the area under the curve thing.
Yeah.
Tell me what f of -2 is. So if I move things around, I think f of -6 is 3. Right? 7 minus 4 is 3. For f of 5, kind of the same thing, except from -2 to 5. So now I need the area from -2 to 5. So that's a triangle plus half a circle, not half of 0, but half a circle, plus another triangle equals f of 5 minus 7. I move the 7 over, and I don't even mess with the rest of that stuff.
You know, don't you?
Maybe I need it later, but until I need it, leave it alone. So that's part A. Area under the curve. I was about to say free points. That's a little bit much. Wouldn't say it's free points. Part B. Part B is about as close to free points as you're going to get. F is increasing. What does it mean if F is increasing? What's positive?
F prime.
F prime. So don't say it's positive. Say F prime is positive. So F is increasing when F prime is positive, and then I just look at my graph, and F prime is positive from -6 to -2 and 2 to 5. That should be free points. Like that should be easy peasy. Part C is a little bit harder because when it says absolute minimum, when I see the word absolute, my brain is saying, whoops, make sure we check the endpoints. And we'll be looking at the critical numbers. Although I don't need all the critical numbers, I just need the relative minimums. A relative max is not going to be the absolute max. So I think, okay, I've got to find f of negative 6 and f of 5. Well, that's convenient. That's what they already had me find. So they pull that trick a lot, where it doesn't always work that way, where you need previous parts of the problem, but sometimes they do that to you. So I've got my 2 endpoints already, because we found those already. And then a relative minimum would happen. I misread the question the first time I did it. Would happen where f prime changes from negative to positive. And that happens at x equals 2. So then I've got to find f of 2. So that was kind of annoying. I was hoping I could get by with just the endpoints, but no. So I got to go do that whole thing again to find f of 2. And then they do make me do a little bit of thinking here, because I've got to pick the smallest number out of 3, 14 minus 2 pi, and 7 minus 2 pi. And so, okay, 3's fine. 14 minus 6-ish is 7-ish. 7 minus 6 point something is 0 point something. You like my math there? So the smallest of those, and it's not really close, so I didn't have to actually do any decimal work. I did have to think about it a little bit. The smallest of those is 7 minus 2 pi. So that is the absolute minimum. It happens at x equals 2. Be careful, make sure I answered the right question. Find the absolute minimum. So the absolute minimum is 7 minus 2 pi. Didn't ask for its location. Part D.
So it's 1 point something something something.
Yeah. But we don't want that. We just want 7 minus 2 pi. Actually, it wouldn't be 1 point something. It'd be 0 point something. Right? 7 minus 6.28.
Oh, yeah. It would be 0 point
0 point
blah, 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 blah,
something. But close enough. They don't put them close where you got to get out of, you have to know pi to the 5th decimal to figure it out. And then lastly, part D, find the second derivative of f, but that would be the slope of f prime. And so that's the key connection there. That's probably worth 1 point. And then, I don't know, maybe this one was worth 3 points. That'd be nice. So the slope at negative 5 is negative 1/2, just slope formula. The slope at 3, though, that's a cusp. So f double prime at 3 is undefined because of the cusp. So I got all 9 points. Congrats to me. But you don't need to get all 9. I mean, if you get all 9 on one, you are set, because that buys you some grace on the other ones. Okay, let me tell you what I want you to turn in, or what's actually due on Monday, and then what's due today before you leave. So the packet's due Monday. On this FRQ, we're only going to do 1 through 6. If you look, there's 1 through 8. In theory, that should take 15 minutes each. That should take 2 hours. That's
too much.
That's too much, yes. So we've already done 1 and 2, and I'm going to ask you to turn in 4 before you leave today. So you got 20 minutes left.
Oh, you mean number 4?
Number 4, not 4 of them. Yeah, that would be a lot. Turn in before you leave. So get started, separate sheet of paper. You're welcome to work together.
What's due Monday?
The entire packet.
The packet, but only 1 through 6 on the free response.
Wait, okay. This whole entire packet?
That whole entire packet,
except for
that we've done more than half of together already, and we still have tomorrow to go over some of it.
64 questions?
Well, we've already done a big chunk of it, Trey. So the packet is due. I'm trying to make it easy to keep up with, so I will give you a packet each week, and that packet will be due the Monday morning. And hopefully by the time we get through with the week, you are most of the way done. And certainly if you've been doing a little bit at night each time, you'll be most of the way done. If you save it all till Sunday night, you'll still be most of the way done, but you'll have a chunk left to do. So again, for that free response page, only 1 through 6 will, well, I guess not even 4 will be due because we're doing 4 now. 1 through 3, 5, and 6 will be due on Monday, along with the video. Don't forget the video. But right now, I want you to do number 4. So you got 20 minutes left. You're welcome to work together. Nice and neat, separate sheet of paper. Number 4, ready, go.